Hello, welcome. This is the first of the S1 tutorials, obviously for Edexcel. Now, what I've got on the board behind me are two different tables. Now, obviously in the exam they give you some hypothetical situation, you know, just a score in a match, or the amount of points scored, or whatever. I've just put score. I don't really care. It's not a real thing. You know it's not a real thing, and more importantly, I can't be bothered explaining the situation. You just get it's a score of something. Alright? You can tell my perseverance is starting to pay off. Anyway. Okay, so I'll go on to a bit about that later, but I just put it there to confuse you and mess with your mind while I try and explain the first little bits. Well, more to the point, I couldn't be bothered giving the introduction and then pausing it while I drew that. So, you know, just give me a few ticks for that. Anyway, okay, so in this video, is what I call the classification of data video. Now, that sounds very intelligent, and clearly it really isn't, because anyone who's trying to sound intelligent, most of the time they're not. They're just trying to build themselves up because they've got an ego problem. So not only is this a maths video, it's also a life lesson. But anyway, you know, there's benefits, and it's free as well. So. Anyway, okay, so in this video, I'm going to start by explaining what the type of variables that you'll meet in S1. And obviously I'm then going to go on to these two tables behind me. One of them is a grouped data, so we've got a score of 0 to 5, for example, and then one of them is simply just a listed table. As everyone, the first line's got a score of 5, okay? And then I'm going to show you how to calculate the mean and the median of the grouped data, okay? And then I'll show you how to create I'll show you how to calculate the mean and the median for both, actually, but the one on the right is a little bit more complicated than the one on the left. So you could just write it out in terms, you could just turn that into a simple showing of numbers, okay, because we know what each number is. And then I'm going to introduce something called coding. Now, I'm not going to go too much into it in terms of, there is a bit more to coding than I'm going to tell you about in this video. There's literally just a few second sort of introduction in this video. What the hell do we mean by coding? And you'll be thankful to know it's nothing to do with using a computer. Maybe that was just me being thick. I thought I should just get out with a laptop and code Microsoft Word. Anyway, and then I'm going to be a nice little thing as well that they might ask you to do, or you might be required to do in some calculation if we've got two of them grouped data tables, for example. So in other words, I'll be just showing you how we combine means. Now you may already know that, and I said it'll only take a second, so it's just something that they potentially could involve you, or in your method you might have to use it to work out something, okay? And then I'm just going to be, I mean I'm sure you know this already, but I'll just be recapping the quartiles, so the lower quartile, upper quartile, etc, etc. And then I'll be talking about the mean, variance, and something called the standard deviation, okay, for, I'm talking about it for this grouped data, okay, and then just a set of data. In other words, just a listed numbers or whatever, okay. Alright, so, and obviously them two were very related, but it's slightly different. Anyway, so the first thing that I was going to mention is what this idea of qualitative and quantitative variables. Now, they might ask you in the exam what's, say the difference between a qualitative variable and a quantitative, or they might say, you know, does this table show qualitative or quantitative results or whatever. But anyway, the qualitative, well, it just simply means it's something that is not numerical, okay, so haircut, for example, therefore, obviously, quantitative, we think n is for numerical, so obviously, if one is non-numerical, the other must be numerical, okay, so quantitative is something, it's just a variable that is numerical, that you could put in some numerical form, so it's just the scores behind me, etc, pretty simple. Okay, so that was just a quick kind of introduction of what I'm doing in this video, and a bit about qualitative and quantitative variables. Now, if you look at these graphs, not graphs, for sake, physics. If you look at these tables, even in a little bit more detail, you'll see the one on the left looks perfectly acceptable. Okay, we've got a score of 5, and there are 10 people. Okay, so this frequency, generally, it might be specified. It might not say it's frequency, it might say it's a number of people who scored 5, but obviously, you know that's frequency. Okay, and then a number of people who scored 8, well, 20 people, and 30 people got scored 10, etc, etc. But this CF, now I've just shortened that because I can't be bothered writing cumulative frequency. Now, you might not, you might have to do that, total them all up, but it's quite clearly just total of the frequency. So you see, the first one is, well, 10 plus nothing is 10, but 20 plus 10 is 30, and 30 plus 30 is 60, etc, etc. So it's just adding up the frequencies as you go along, okay? But this other table, now, depending obviously where you are, if you're doing this from, straight from GCSE statistics, or if you didn't do any statistics at GCSE, obviously we'll have varying degrees as how you see this. But at GCSE, if you did do statistics, then you probably won't be too happy with this table that I've drawn. Primarily because what we've got here, you've got a score of 0 to 5, but then if you look in the next row, we've got the score of 5 to 8, and you go, whoa, 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 back up a minute. I remember my teacher saying at GCSE that we can't have this overlap. So in other words, if we've got a score of 5, which do we put it in? Do we put it in the 0 to 5 column or the 5 to 8 column? Now, I have to break your heart just again. In GCSE, you were lied to. Not only in chemistry, but also it now turns out in maths as well. And they weren't necessarily lied to. The only reason he said that was to make the question easier for thickos to understand. Now, obviously you're A-level, so you're not thick. Well, that's one you might be doing this at GCSE, so that just insulted you. Anyway, the principle behind this is just the fact that we say, well, 5 can either lie in the 0 to 5 row, or it can lie in the 5 to 8. And the reason, that, I can't really give too much about it away until we start actually doing about the median of this. And in essence, we're going to use something called linear interpolation, okay? And linear interpolation, okay, so if we put a score of 5, if we basically, so I can't really explain without going too much into detail about the linear interpolation formula, but you just think of it as a fact that 5 is the extremity of that group, which is also the minimum of that group, okay? So if these people, now, I don't want to I'm trying not to give it too much away from it, but basically we've got 10 people who scored between 0 and 5, and we put a midpoint because this is groups. We don't know what score they got, so we assume most people got a score of 2.5, if not all of the people in this group. Okay, so if we're looking at the 10th person, okay, if we're looking at what score did the 10th person get? If we're assuming this, if you were to draw this out, say for example, we now knew all the values of the scores in this second table here. If we knew all the scores in that table and we were to write it out, okay, we'd assume the 10th person, if being in chronological order obviously, would have the maximum sort of maximum score in that group. Now, as I said, I don't know what score this is meant to be representing, mainly because I've just made it up. But you wouldn't get a score of 4.999 goals, would you? You'd go on forever and ever and ever. And that just, we can't have something like that in maths, apart from x and y axes and etc. Loads of examples. But just in this area of maths, we don't. Okay. So if we're looking at the 10th person, it's likely to have a score of 5. Which, as I said, does not make too much sense, but I promise you, when we go into the linear interpolation, it will. Okay, so I'll probably start computing there. But if you just accept the fact that we need an extremity, which is an integer, essentially. Okay? And obviously 4.999 isn't 1. Okay, so hopefully that's cleared a little bit of that up. Now, as I said, you could, because we know the score of this table, the table on the left, you could simply write it out as there's 10 people who got a score of 5, so you write 5, 5, 5, 10 5s, okay? But the reason I've done this is just to show you, because there obviously are different formulas for calculating a mean and a mode for each corresponding table. Okay, so I think actually probably it's a good point. It's a good idea at this point just to explain what we mean by linear interpolation, because I have mentioned it, but I've just said, oh, we're going to use it in a second, and just kind of try to not allude to it, and now I'm going to allude to it. So anyway, sorry about that. Okay, so linear interpolation, the formula is essentially this. Okay, it's the lower bound. I'll explain what that is of in a minute. Plus, and then you, in brackets, the number of places into that group, or places into group, over the group frequency times the group width. Okay, so what the hell does that all mean? Now, my first question is not why am I doing this, it is what is this lower bound of, okay? So, first of all, what do we mean by the lower bound? Well, the lower bound is simply put just, so if we look at one of these, so let's take the last row, okay, the score of 10 to 20, the lower bound is just the lowest score in that group. So in other words, for the 10 to 20, it'd be 10. Now, this kind of reiterates why we've got this, looks like an overlap in the groups. Because this lower bound is not going to be 10.111, whatever. Okay? That wouldn't make any sense at all. So what we need is, we need it to be an integer, okay, so 10. So it's the lower bound of a given group. Alright? Now, how do we know how far to go into that group? Well, obviously, it all depends on what you're working out. Now, we're told, or what this works out, that the cumulative frequency of all of both is 65. Now, quite clearly for this, we're going to be looking at the, So you want to calculate the median. This is what we use linear interpolation for. Now, if we were to calculate the median of the left-hand side group, in other words, we look for the one in the middle. Okay, so you would divide 65 by 2, okay, which I think is 32.5. Yeah, 32.5. Okay, so yeah. So I'm just about to concrete there. 32.5. Okay, so you would look for, because this is one of the things that I want to bring up. So if you half a number and it comes to a decimal, in other words, if it's an odd number, okay, because you get 32.5, you round it up. You go, we'll choose the 33rd number. So you look for the 33rd number, okay? Well, what does that lie in, okay? So, obviously, the 33rd number is going to be 10, okay? If we put it in chronological order, if we look on this one. Because we know that's a specific number, because all them 30 people scored 10. Okay, so the 33rd is going to be in the 10 group. However, when we look at this, we do the same thing. We want to work out the median. We half 65, get exactly the same answer as I said, 32.5, but we don't round it up. Okay? Okay. Now, oh sorry. No, there you go. Okay, so how the hell are we going to work this out? Even if we did round it up, just the reason I'm not rounding it up is because we're going to sub into this formula. So, if we were to, well, we don't know. We think everyone scored 2.5 in the first group and 6.5 in the second, etc., etc. But we don't actually know that for certain. We're just estimating, okay? So we need to come up with a better estimate. That's just a very, very generic estimate. We use this formula to help us find the median. Okay, so we look what group the 32.5 number lies in. Okay? Well, it's going to lie in the same group, okay, as that the one on the left did. However, this is the group 8 to 10, okay? And because... Oh, sorry. Did you round it up? Yeah, because it lies in the group 8 to 10, you use all the information from this and apply it to the group 8 to 10, okay? So the lower bound of the group 8 to 10 is 8. And the number of places into that group, okay, well, it's 2.5, okay? So you put 2.5 into that. And the group frequency, well, that's just 30, okay? But what the hell do we mean by this group width? Well, the group width just means, well, in this case, 10 take 8 is 2. Now you need to be aware, it might not be giving you in this overlapping form, so you may need to rearrange this in terms of, it might say 6 to 7, okay? Because they leave a gap between 0 to 5, 6 to 7, 8 to 10, okay, etc, etc. So you may need to make it look, the groups like this, okay? And that obviously would affect your group width. Now if you think about this logically, it works. Because it's almost like a ratio of how far into that group you want to go. Now, we know it's going to be the lower end of... It's going to be more towards 8 than towards 10. Because it's only 2.5 into the group, okay? And the group's got a frequency of 30, okay? So therefore, it's like, what we're doing here, essentially, is... we're adding on the lower bound, because, well, that's the minimum in that group. And this is like... what the bit we add on all of that fraction and times it, it's almost like a percentage of that group, okay? I know we're not times it by 100, but you have to think of it like that. We're simply just saying, so if you think about this as a maximum, so if we were going right at the end of the group, okay, so if we were on the 30th person in that group, okay, what we'd be doing is 30 over 30 times the group width. In other words, 30 over 30 is 1, so it's just the lower bound plus the group width, okay? Which would be the end value. So this works. It's not just randomly come up and doesn't make any mathematical sense. That's why there's no really maths behind proving it at all, because it's just logic. I know some people don't do logic, but unfortunately for them, some of us do. So that works, okay? So hopefully that makes sense why we've got that exact formula there. And I'm just going to double check, I don't have to round it up actually. When I say round, I mean this value. Because I know we've got the same number as in the left hand side table, but I just need to make sure. So I do apologise. Sorry, I'll need to double check. Probably just one sec. Just pause the video, just double check you don't round it up. Hello, so I just wanted to check that you didn't have to round. You didn't have to round the 32.5, and you don't, because it's grouped data, so we don't know the exact 33rd number, okay, so that's why we leave it unrounded. So whatever number you get, you leave that as it is, okay? So then it's just a case of summing it into the formula and getting an answer. Now, obviously, it will be different for the left-hand side table to the right table. In other words, this, because they are, even though they look the same table, as I said, the one on the right is grouped, okay, so we don't know the values. But the one on the left is just a single table, so we do know the values. Okay? So that's why you get different values, even though they look the same. Okay? So anyway, that's just kind of a quick introduction. What I'm going to mention now is something called coding. Okay? Now I said it wasn't anything to do with a computer. Okay? So you don't have to whip out a laptop and start writing up some IBM codes. No, it's much simpler. Now, as I said, this is just an introduction. It's simply just something as simple as it might give you a coding figure. Okay, say our score was our x value. Okay, and our frequency was our y value. Actually, yeah. Okay, and I'll explain why I've given one x and one y. Okay. Alright, so it might say x is equal to m take 100, for example. That might just be a coding value that you get. So every x value is equal to an m value minus 100. It might ask you, when we go later through the course, it will ask you something about correlation and regression, okay, which sounds weird if you've not gone through it already, but it is very simple, okay. But as I said, it might just simply ask you to convert values. In other words, you would have to convert each x value into an m value, or vice versa, if you got the m value already. Okay, and similarly for the y, it might say y is equal to z plus 200. Okay, so then it's just a case of rearranging and subbing in your y values. Okay, so almost like creating a new table sort of thing. And you would never be asked to do that on a grouped table, okay, because we don't know a specific value. Okay, you would only be asked to do that on a table where you know exactly the value, so such as the one on the left there. Okay, so that's what coding is, but there is a bit more to it that we'll go on to look at later on. Now, just to give you a bit of a heads up, you might not necessarily understand what is meant by this, but the sentence that you need to know about coding, apart from the fact you need to change all the individual values, if you do a relationship, so in other words, if you have something called the product movement correlation coefficient, which is a fancy way of saying, well, what's the relationship between x and y, such as the score and the frequency, but it might not just be the score and the frequency, it'll be two different values, okay? And the PMCC, product movement correlation coefficient, just simply it says what's the relationship between x and y, and if you code each of the values, in other words, if you change each x value by the same amount and each y value by the same amount, the correlation will stay the same, because you can think of the correlation as being kind of the gradient kind of thing. Okay, so the gradient between x and y will stay the same if you plot a graph of x and y, for example. Okay, so a very, very easy thing to understand. Now, you might be going, well, sometimes it doesn't necessarily tell you which is the x value and which is the y value. Okay, and really, I know it doesn't necessarily work for that table because I've just come up with which one was x and which one was y off the top of my head like that, just to show you what we meant by coding. Okay, but it's key to understand. Well, if you think the best way to do this, especially if you did science for GCSE, this will help. Okay, so we draw our table. If we draw a standard graph, okay, we've got the y-axis and the x-axis. Okay, and whenever you plotted your results, okay, on a graph, you had the independent variable on the x-axis and you had the dependent variable on the y-axis. Okay, so using that same philosophy, that means the x values must be the independent variable and the y value must be the dependent variable. And you may be going, well, great, but if I'm not told which is the independent, which is the dependent, so if I don't know what x and y is, how will I ever know? Well, sometimes it's just obvious for people, it just comes across naturally, they will just spot it, okay? But the method I use, if you're not 100% certain, you say there's this very common, well, not common, obviously, you will say one value influences another. So, in other words, the score influences the frequency, or does the frequency influence the score? Now, obviously, neither of them make sense because they're not proper x and y values, they're just numbers in a table, okay? And they're not two different sets of data, okay? Now, as I said, I've just given them x and y, but they're not really variables. That's a crap explanation. But you will have one, so give it, actually, a good example here. So you've got one variable, I think this was actually one of the questions for past exam, and it said you've got so actually this is going past this topic, I'll mention this again, so it doesn't make sense. I would mention it in a later video. I think there was a question a while back where it said, we've got a height above sea level for a town and the temperature, okay? And you say, does the temperature influence the height above of the town above sea level, or does the height above sea level influence the temperature, and it's obviously the later one. So the one that influences the other is the dependent, okay? Is the independent, sorry. And then the one that is influenced by the other one, that is the dependent, okay? So in other words, related to that house above the sea thing, so we said that because one of the sentences will always make sense, because it doesn't make sense that the temperature influences the height. It's the height that influences the temperature, okay? So therefore the height, doesn't matter what it is, okay? The temperature depends on whatever the height is, okay? So the temperature is the dependent and the height is the independent, okay? That was just an example. As I said, it doesn't really matter. I'm just trying to give an explanation to why we give an x and why we give a y value. But I will be mentioning all of that a little bit again, so I don't know why we really wasted your time. But, you know, you'll be learning it anyway, especially if you're just doing the whole course, okay? So that's what coding is. Okay, so this next little bit is about combining the means. Now, this is kind of not necessarily a question you will be asked on in the exam. It won't say this is the mean of one set of data and the mean of another. Find the combined overall mean. Now, maybe I've just not seen that question in the exams and I've just missed it. But either way, it's not a very common question. So if you don't get it, it doesn't really matter. It's not the end of the world. It's the end of the world when you die. But since you're not going to die, although probably I was going to look at an imaginary watch I've got on my arm there, you probably will die through the length of this video. Anyway, cheer your thoughts. So the mean, you generally know, we call it x bar. This by the way, a bit bigger, that is the symbol that you will see. If you see that symbol, that just means the mean of x. Similarly, if you add y bar, now I say y bar, it's just y with a horizontal line above it, I call that y bar. That's the mean of x, and that's the mean of y. Okay? But let's, for simplicity, just say we've got two means of x. Okay? So I call it x bar 1, so that means x bar and then subscript 1, little 1 at the bottom right of the x. That just means the mean of x of data 1, okay, equals whatever it equals. Okay, and then similarly, the mean of x2 will equal something else. So what we've got here is I've just got two values of x, okay? So we've got two sets of data and we've found the mean of these two sets. Now, obviously it's irrelevant because I'm going to show you how to work it out. Now, we'll put some numbers attached to this. Okay, so we'll get a value for them too. But what's the overall combined mean of the two, okay? So what's the overall mean of x? Because you might not necessarily know what is the individual values of the data in x1 and the individual values of the data in x2. If you knew that, well, you could just do it like you were working out the mean of anything, okay? You would add up all the numbers, divide by how many there are, quite really, really simple stuff. But say, for example, you only knew the amount of numbers, okay? So the numbers in the data of x1, okay? And similarly, you only knew the amount of numbers in a set of data x2, but you knew the means associated with them two sets. How would you work out the overall combined mean? Well, it's very kind of simple formula. What you do is you do it's a division, okay? So it's the number of so it's n1 times x bar 1 plus n2 times x bar 2, okay? And that's all over n2 plus n1. Now what does all that mean? Well, just apply what I said before about what n2 meant and x bar 1 meant, etc, etc. In other words, the overall mean is the number of numbers, if that makes sense, in data set 1 times the mean of data set 1 plus the number of numbers in set 2 times the mean of set 2 over the total numbers in both. Okay? And that's how you work out the overall mean. But as I said, if you knew the individual numbers of each set, you would just work out as you were working out any other mean. So you might have to do that in some part you're working out, but as I said, it's nothing too, you need to understand, okay? Because I don't think I've used it in an exam, so I don't see the need for you to either. Okay, so anyway, moving on to the next bit. So this is more at the end, really. This is kind of the most. Oh, actually, so I've got inequality. Sorry, inequalities. Economics. quartiles. Can I say quantities? Quartile. Well, you know the standard, very, very easy identification, okay? Well, we've got the lower quartile, okay, which is equal to a quarter, okay? So the lower quartile is the first quarter, and then we've got the median, okay? Now the median we actually label as quartile 2, okay? So we label the lower quartile, which is a quarter of the way along the spread of data. We call that, you might see that written as Q subscript 1 or Q1, okay? You'll see the median is written in a similar way as Q2, in other words, the second quartile. And following this pattern, you will see the upper quartile labelled as Q subscript 3 or Q3, okay? And obviously, therefore, you would have the two maximums as well. So the lowest number would be Q0, and the maximum of the range would be Q4, okay? So you got, I know you got essentially 5 quartiles there, but we didn't really consider these 4, okay? So you got 4 quartiles there, and as you all know, as I said, you probably did this from GCSE, but the interquartile range is the upper quartile take the lower quartile. Now, I did introduce something when we tried to find. Now, I'm going to apply this theory to group data. Okay, so a question could say, it could give you that exact table, the right-hand side table, the group data one, and say, right, find the interquartile range. You could do that for table 1, but if it asked you to do it for table 1, you could simply, depending obviously how many numbers were, there's quite a few there, but you could simply just work out logically what would be the middle number and up quartile, etc. It's just a case of logically counting, but they would never ask something like that. They're more likely to ask in group data form and say, find the upper quartile, find the interquartile range. Now, obviously, as intelligent people, you know the interquartile range is the upper quartile take the lower quartile. However, it's not so obvious in this one. What's the upper quartile? What's the lower quartile? Well, I showed you how to calculate the mean, and we did that using something we call normal distribution. Oh, God's sake. Sorry, not normal distribution, the linear interpolation. Sorry, I was getting ahead of myself thinking, I've already finished all these S1 videos, and I haven't, so I do apologise. By the way, normal distribution is something we come up with very, very last topic, so that's how far ahead of myself I was. Anyway, but that is a very, very easy topic. Even though it sounds difficult, it's really not. Okay, so anyway, as I said, you worked out the mean, as I showed before, using linear interpolation. And I said the formula for linear interpolation was the lower bound plus the number of places into that bound over the frequency, or in other words, the total amount of places in that bound. I'm just going to label it as the frequency times the group width, or times the group width. Now, I did say that the group width was essentially this, the difference between two numbers, okay, 10 take 8. And the total frequency was the frequency of that group, and the number of places in was, well, it depends on what you're trying to find out, okay? And I did say they might catch you out by saying what's the lower bound? Well, it's just the lowest number in that given range, okay? Whatever group it might be you're looking at. So if that works for the median, because that is quartile 2, but it works for a quartile, so there's no other way of putting it, it works for the other quartiles in the range as well. And you use the same principle, in other words, of trying to find out, well, what number is it in the lineup? Assuming these are spread out evenly between 0 and 5, 5 and 8, etc, etc. When I say spread out evenly, the numbers, because there's 10 people who score between 0 and 5, we assume it to be spread evenly between 0 and 5, so each person gets half a score, for example. But obviously that wouldn't happen, just trying to make sense. If it doesn't, ignore me and you put on a bit of club music or whatever you listen to anymore. Anyway, okay, so worked out for median for the quartile 2, in other words, a median. You halve to 65. Well, as if you were trying to work out the lower quartile, you would divide 65 by 4 and the number in. Okay, so if we divide it 60, actually I'm not going to do that because I'll probably make a hash of it, as I don't have the thing with me, calculator. Divide 65 by 4, get an answer for that, and you look what group or what score that is in. We label the score as a group, that's why we call it group data. So you look what score category that is in, you see how far it is into that group, and you apply the same principle as we did for the median. And as you did for the lower quartile, obviously you need to work out the upper quartile as well. Okay, so you simply just sub in the same number, not same numbers, you use the same method, okay, but obviously you need to times it by 3. If you work out a quarter, so you need to work out 3 quarters. See, you don't just times your answer. So this is the key thing actually. If you worked out the lower quartile, okay, and you just think, well that's a quarter, I'll work out whatever that is and times it by 3. Well, no, okay, because all you're doing is working out the lower quartile and times it by 3. It's not working out the upper quartile at all. You times, obviously you could do 0.75 times 65, or you could do 65 divided by 4 times 3, whichever way you want to get 75% of quartile. Okay, you work out what that number is and then sub into the linear interpolation formula. You don't just work out the lower quartile value, times it by 3, because you're kind of skipping the whole equation. And even though that's easy, and you probably wouldn't want to do that, this is maths and we want to make you work that a little bit harder and waste that little bit more of your life getting confused. So, welcome to hell. Anyway, okay, so then it's just a case when you've worked out the upper quartile and lower quartile, there's no necessary working out the median, it's pointless, unless it asks you to, obviously. In which case, obviously, weirdly enough, you do have to do what it asks, unfortunately. I mean, you can do what it doesn't ask and work out the upper quartile, and it works out the lower quartile, you probably get shot. And as I've seen, I probably don't want to advise that so much. Probably wouldn't be too good at it. But anyway, you get a value for the upper quartile, the lower quartile, by simply using this linear interpolation formula, like you did for the median, as I said, and then working out the interquartile range. Okay, so that seems very, very simple. And it is, okay? So we haven't actually done too much that is new in this video, apart from the fact that we've introduced this this idea of group data, okay, in this overlap business, which seems a bit weird because you go, why the hell will we put 5? That looks like it's in 2 categories. As I said, I tried to give you an explanation on that, and why have we just got this, put this we put this linear interpolation formula from for no reason. Well, I tried to give you an explanation to that as well, and I can't bother giving it again, so, stuff you if you can't remember. Anyway, right, there's one more thing that I want to do. This is, along with the linear interpolation formula, one of the most common things they ask you to do with group data in S1. Now there's 3 things, okay, that you know way back from GCSE. Obviously the mean, the median and the mode. Now obviously you can simply spot the mode from the graph, okay, sorry, I keep saying graph. Table, if it gives you this, okay, you will simply read off and it's got the highest frequency. If it gives you a group data, you'll read off the number which the midpoint has got the highest frequency associated with it, so obviously that would be 9. But what about if I asked you to do the mean, or something we call the variance, or something that we're going to introduce now and we call the standard deviation? What the hell? I mean, first of all, how would we calculate the mean? And what the hell do the other 2 values mean? Well, the variance and the standard deviation, okay, are very, very closely linked. So if you remember the formula for one, you're going to remember the formula for the other. However, they're not necessarily understandable until we start getting on to something called normal distribution. Now, I do just want to give a bit of an introduction to that a bit later on, okay, when I've showed you how to work out the mean. And that's because if you understand it now, then when you go on to learn the topic of normal distribution, assuming you haven't yet, they're very, very closely linked. So there's no rush at all in trying to figure out which one to do. Okay, so the mean. Well, for the table on the left, it's very, very simple. You would just add up all the numbers and divide by how many there are. Okay, and that will give you an average. Mean average. Okay, so it's very, very simple for the one on the left. for this variance and standard deviation, how would we work that out for the table on the left, the individual data? Because that's easier. So let's start with that. Well, as I said, the mean you would calculate. I'm going to label it as x bar because that's the kind of notation you need to be able to understand. Well, that was just the sum of x, okay, over n. So that's what the mean is. Now, what the hell are these variance and standard deviation? Well, I'm going to try and give a bit of a background before I shove the formula on the board. Okay, sorry about that. Just had to put in the camcorder. I just saw the inevitable little red battery light as it's had enough of me talking. Anyway, so that's what the mean is. What the hell does this variance and standard deviation actually mean? Well, as I said, they are related to each other. Okay. Now, the best way of explaining it is through normal distribution. Now, I'm going to draw this graph, and it may look ridiculously weird if you've never seen it before, but it will make sense, and it will hopefully make the normal distribution topic a lot easier. Now, what this is meant to be is kind of a symmetrical shape. Okay, I'll try and have another go at it because it needs to be quite well drawn to be able to understand it. Okay, so it kind of looks like this line. Obviously, we've got our x and y axis here. Okay, so it's basically a shape that's symmetrical about the x and y axis. Okay, and it sort of increases gradient up to a peak. The peak, by the way, is on the intercept of the y axis. Okay, and these lines, they don't necessarily go up to touching the x-axis specifically. It doesn't really matter if you show that or not, but they probably would do in the end. Anyway, yeah, they would. Sorry, yeah, they definitely would. And there's a specific point where they would that you need to know. Anyway, what this is showing a graph of probabilities. Now, I know this is the y and the x-axis, and you think dependent and independent variables are related to corresponding ones. But necessarily. Now, it's not necessarily a graph of x against y. It just says that's the x-axis, that's the y-axis. It's just a statement of probability. Now, on the x-axis, we have something called the number of standard deviations, and it's written by this little sigma thing, and it's like sort of like a crap musical note on its side. Well, I don't not to say music crap, but it looks like a crap version of it. Maybe just I can't draw it. Okay. And what we have is a maximum on either side is 3 standard deviations. Now on the right hand side we have 3 positive standard deviations, and on the left hand side we have 3 negative standard deviations. And where the origin occurs, okay, or in other words, where x equals 0 at any point, so where y along the y-axis, that point is called the mean. And it's symbolized by the letter mu, which you'll be very familiar if you do physics. If it's not, it's just like a back to front U. Okay? And that represents the mean. Okay, so you might see the mean written as x bar, you might see the mean written as this weird U shape. Okay, which appears to be back to front. Okay? So what this is showing, and I'll relate this to the variance of standard deviation in a minute, well kind of related to standard deviation. The standard deviation, it's always 3 either side of the mean. Okay, the standard deviation is a formula for it. Now, that'll help you understand normal distribution if you remember that fact for normal distribution. But this shows a probability. Now, we know there's a probability equal on both sides, which this shows because it's symmetrical, so there's a 50% chance on the left hand side and a 50% chance on the right hand side. So therefore, the probability from y upwards is 0.5. Now this is not always the case, but this just helps you understand the variance and standard deviation. Sorry, it's not always 0.5, it might be, it's always 0.5, what am I going on about? It's always 0.5 because there's the same standard deviations away from the mean, okay? It's the same area, we assume there's the same probability either side of the mean, sorry about that. So the standard deviation, you could like, well 3 standard deviations always is 0.5 probability, okay? Well, not all, but what it's trying to show here is the standard deviation. The mean will have, it's basically, obviously the standard deviation changes for each spread of data, okay? But it's with 3 of them on either side of the mean, okay? So the variance links, because it says, well, how spread out is that, okay? So how spread out is that 0.5 probability on either side, because it might be a greater spread, okay, on the right hand side to the left hand side. Now I said it is symmetrical, and the standard deviations are the same, but it might be, it'll make sense when I do normal distribution. But anyway, this variance, in other words, this is trying to show that the standard deviation on either side of the mean will be the same. In other words, it'd be 3 on the right hand side, it would be 3, in terms of what I mean by right hand side is left hand side, is positive and negative. Okay, so the right hand side is positive, left hand side minus. So it's the mean minus 3 standard deviations. Okay, and you will have 3 standard deviations on each side of the mean. The variance just shows, well, how spread out is that over the mean. Okay, so how much is 3 standard deviations? If that makes sense. If it doesn't, don't worry. It's not 3 standard deviations divided by 3. It's not that at all. It's just showing how spread out is it. That may not make sense. It might. Okay, but if that makes sense, great. If it doesn't, just have to learn these formulas. And to be honest, I think they're given in your formula sheet anyway. But I always just learn them because they are very, very easy to learn. Now, I said the variance and the standard deviation were linked, okay, and they are, okay. So if you remember the formula for one, it's just a very simple manipulation to remember the other one, okay. And there's no other way of putting this. We know we build up to this, and you don't need to have it created at all. So the variance, well, I'll just call it the variance, and I'm not going to put V because that might confuse people who do physics, okay. So it's the sum of the squares, okay. So the sum of x squared over n, okay. So it's the mean. But instead of adding the x value and then dividing it by how many x values there are, each x value you add is squared, okay? So if, for this example, it would be 5 squared plus 5 squared plus 5 squared, etc., etc., plus 8 squared plus 8 squared plus 8 squared. So hopefully that makes sense. And you will take away from that x bar all squared. In other words, the mean squared. So you could write that as the sum of x squared over n minus the sum of x over n. And now that it's not just the sum of x over n, because you will take away the powers, but it's not. That would only work if you're dividing it, and you're not. Okay, so that's the variance formula. The standard deviation, which as I said I'm going to write as that crap musical note, which is what you'll commonly see as, is labelled as the square root of the variance. Okay, so you just do the square root of that formula. I'm not going to write that formula out again, I can't be bothered. Now, what about if we applied it to the table on the right, which was asking about grouped data? Well, obviously, you can't say, well, just sub in the... Oh, sorry. Actually, I've got this wrong. That is not for that table on the left. That is just for a set of data. Sorry. Yeah. If you were doing it for, well, it would work for both, actually, to be honest. Yeah, so that would work if you were writing out a, if you were just choosing from a set of numbers. And it would work for the one on the left as well. Now, the reason I said it wouldn't, because there's a simpler way of doing it. Because we've got 10 5s there, okay? Instead of adding 5 plus 5 plus 5 10 times, we can times 5 by 10. In other words, we're timesing the x value by the frequency. So instead of adding the sum of the sum of x's, we can add the sum of frequency times x, because that will make the calculation a lot smaller. Okay, so hopefully that makes sense. So when we do grouped data, okay, and this works for the one on the right as well, and I'll explain the difference in a second. Okay, you do the sum. I can't do the sum sign very well. The frequency times x over n, and that's the mean. And then for the variance, it's a similar thing, where instead of saying it's the sum of x or the sum of x squared, okay, it's the sum of fx squared. So we're still adding, the x squares, but we're timesing each x squared by its corresponding frequency. So we don't have to keep adding x squared plus x squared plus x squared 10 times, or whatever it is. Divide by n, and then it's take the same x bar squared. And the variance the standard deviation doesn't change from the square root of whatever the variance is. And you could work backwards by saying, well, therefore the variance is the standard deviation squared, okay? So that's what you do. Now, as I said, these two methods work both for the table on the right, because if you use the first method, which when I say the first method is the one that I've not all boxed off, okay? So the sum of x is the mean of x is the sum of x over n. The variance is the sum of x squared over n. Take x bar squared and take the mean squared, and the standard deviation is the square root whatever the variance is, or the variance is standard deviation squared. Now, they are written, when we apply that to normal distribution, they are written given slightly different symbols, but as I said, sorry, actually no, they're not. You'll mainly see this sideways musical note in standard deviation. But there's a bit of a notation that goes with that we'll work on later on. Okay, now as I said, they both work for this table. But if you use the first method, okay, you have to add 5 plus 5 plus 5 for the sum of x 10 times. So really, if it's any group data, I would always use the one in the box. However, you may be going, we don't know the x value for the group data because we don't know the individual x value. Now you said they're evenly spread out between 0 and 5, but we can't just pick evenly spread out about 0.5 because we said that would mean each person would have 0.5 of a better score than the previous one, and that can't happen. Think of it as a goal. You can't have half a goal. Okay, so what they do instead is they choose the midpoint. And now I know that's 2.5 and you might be arguing, oh, well you just said you can't have half a goal, so why could you have 2.5 of a goal? Well, point proven, and I don't really care to be honest. The point is, there's a point, that's where you assume, that's just a generalisation of it. Okay, so this x, when it's related to a table which has just got a value, so like the one on the left one, just got that the score of 5 has got a frequency of 10. We know each of them 10 people has got a score exactly of 5. Whereas the table on the right, the group data, we just assume it's halfway between because, well, that's a best guess. That's what it's average. You would assume that. Okay, given that we don't have any other information, and for S1 you won't do. You don't have to worry about anything else. Okay, so that's the variance, the mean, and the standard deviation. So very, very simple. Okay, so that's the end for this video. And as I said, I could do a few questions, but I can't be bothered. Okay, I know it sounds typical, but what you're going to do? Absolutely nothing. But really, if you do want me to do some questions on that, please do let me know on anything that we've done in this video so far, but mostly live. But as I said, it's just summing numbers into formulas that we've discussed today. And to be honest, it's just as simple as, well, me. Okay, so as I said, it's very, very simple. There's nothing too difficult about this topic at all, and nothing really too difficult about S1 at all, which says the reason why I'm redoing it. I've only got 67% last year. But anyway, 100% this year. Okay, so thanks for watching. Hopefully it's helped you, and as I say, if you want me to do any questions through these, I will just trying to get through S1 and upload them all before the exam, so you get a chance to waste some more time for the exam. Okay, so thanks for watching, and we'll see you in the next video.